Hello and welcome to Roots and Powers, our first worksheet being Radical Dude. Some hikers traveled 2 kilometers north and then turned east. So let's just kind of review which way. North we write at the top, and then there's south and east and west. So if I'm going to draw a diagram of that, we're going to say, all right, here's where they started. And they went 2 kilometers north. Ended up here, so that's 2. Then they went east for 5. So that's 5. And the question is, how far are they from the original position as an exact value, right? Which means leaving it in square root form. And we remember that from measurement. So what we're going to do is draw the straight line as the crow flies. The crow flew from here to here. This is, let's call that d for the distance, so we know that d squared is equal to, since north and east are 90 degrees apart, right, all of the cardinal directions, we have 2 squared plus 5 squared. D squared is 4 plus 25. D squared is 29, and so we unsquare using the square root, and we get d is the square root of 29, which is an exact value, right? Square root form, and you remember that from measurement. Sam has about 500 cubic centimeters of Play-Doh that he shaped into a cube. Determine the length of the cube. Okay, so a cube, right, has all sides the same length, which I have not drawn a very good cube. That's more rectangular prismy, but we don't need a diagram, right? We need the volume of a cube is the side length cubed, and we are given the volume 500 is s cubed. So we write s cubed is 500, switching sides, and we're going to uncube, and that's called the cube root and indicated with a little 3 down there. Cube root 500. And that's actually in centimeters, as I guess this up here is in kilometers, right? The exact distance is root 29 kilometers, and the exact distance here is root 500 centimeters. And square roots, like root 29 and cube root 500, are examples of radicals. For radicals. Here we go. 3 squared is 9. Since 9 is the square of 3, we say that 3 is the square root of 9. And it's read like this, with a little 2 there, which indicates which root. 3 cubed is equal to 3 times 3, which is 9, times 3, which is 27. Since 27 is the cube of 3, we say that 3 is the cube root of 27. And that's in English, and 3 is the cube root, so we're going to indicate that writing a little 3 in here of 27. 3 to the 4th is 81. Since 81 is the 4th power of 3, we say that 3 is the 4th root of 81. Okay, and again, this indicates which root. 3 to the 5th, 243, right? We're just multiplying this by 3. Since 243 is the 5th power of 3, we say that 3 is the 5th root of 243. It's the 5th root of. Indicate 5th root, we put a 5 in here, that's the index, and we write the number 243. And yeah, here I'm going to extend this out. This should cover the whole radicand, actually. Expressions such as the 4th root of 81 are called radicals. A radical consists of an index that tells you what root, the radical sign saying, hey, we're taking a root, and the radicand, the thing which we are taking the root of. Most commonly, we do square roots. So the most common index used is a 2, and so when we don't write it, it's a 2. So if no index is written, it's understood to be 2. And you are very rarely going to see an index written. Complete the following table. Okay, so the index is 4. the radicand, the root. What, we're taking the root of what? Of 16. Which root? It's the fourth root. Fourth root of 16. And what's that mean? It means that we have to take a number multiplied by itself 4 times to get 16. A number times itself 4 times to get 16. So what times itself? 2 times 2 is 4, times 2 is 8, times 2 is 16. This is read as the cube root of 125. It's read as the cube root of 125. Let's fix that u. So cube root has an index of 3, cube root, the radicand, the number which we are taking the root of. And this means a number times itself 3 times to get 125. And that number is 5. 5 times 5 is 25. Radical, this is read as the square root of 49. So I'm going to do the read as first. Square root of 49, because we know if the index is blank, it's a 2, right? It's a square root. So the index is 2. The radicand is 49. It's a number times itself, and I don't need to write 2 times, just a number times itself is 49. So what times itself, what squared is 49? 7 squared is 49. All right, let's go talk about the roots a little separately here. Let's talk about square roots first. If x is the square of r, then r is the square root of x. So written symbolically, so if x is the square of r, if x is equal to r squared, then r is the square root of x. Some numbers have a square root, but there are some numbers, actually a lot, for which you cannot take the square root. Which numbers do not have a square root? Well, when you number by itself, you cannot take the square root of a negative number. So we say the square root of x exists only if x is greater than or equal to 0. You can take the square root of 0. It's just 0. If x squared is 9, if I square a number and get 9, well, 3 times 3 is 9, but so is negative 3 times negative 3. So a positive number has 2 square roots, one of which is positive, one of which is negative, since a negative times a negative gives you a positive. This is so extraordinarily important, solving this all the way through math, where you must remember that when you are solving, something squared is equal to something that you get a positive root and a negative root. So a positive number has a positive and a negative square root. That's when we write something like this, like what's x? Well, 3 squared is 9, negative 3 squared is 9. When we write it in radical form, this means only the positive square root. Okay, so if I say root 9, I mean only 3. When I say x squared equals 9, I'm saying what number, when squared gives you 9, we get 2 values, 3 or negative 3. When we say the square root of 9, this radical symbol, it is only the positive value. Okay, pause the video, get your calculator out, and label the first 15 perfect square numbers, and I'm going to pause, and I'll be back in a moment. Okay, I'm back. I filled this in. You could verify this. This should be what you have written down. These are all the squares, and you really need to know these off by heart, probably up to about 15. Okay, and the first 10 you should know pretty well. You might have to work on these a little bit just to make sure that you have them down, or at the very least recognize that they are squares: 121, 144, 169, 196, 225. And since they are squares, know that you can find a square root. But not every number is a perfect square. Their values can be estimated by comparing them. So like without a calculator, estimate the following. So the root of 20 16. So we know it's between 4 and 5. And it's 4 units from 4, and it's 5 units from 5, so it's going to be in about the middle. So let's estimate that at 4.5. Okay, and I'm not going to estimate to like 6 decimal places or anything, right? We'll only estimate to 1. Root 85 is between 81 and 100. It's 4 units away from here, 15. So it's closer to 9. So I'm going to guess, and I really am guessing here, I'm just going to say it's 9.2. And the root of 200 is really close to 14, right? It's like 4 units away from there. It's 25 units. So let's say 14.1. Okay, let's toss an equals in there. And use a calculator, so let's get our calculator up. Okay, so here's our calculator. I'm only going to do the first one, and then, oops, whoa, we're going all over the place here. Okay, I want that. Okay, let's turn that on. Let's clear this. So we go second function. Here's the square root, right? It's the inverse of the square function. And 20, and hit enter, and we get 4.47, which is 4.5, rounded to the nearest tenth. Root 85. Now I can do this. I can go second function, enter, say bring back the last number. I'm just going to arrow back over and write in an 85, and we get 9.2. Okay, so far so good. Batting 1,000. And we are batting, 1,000. And this is 14.1. So the estimates here were actually the values rounded to the nearest tenth. Okay, let's keep moving. Square root of 1/9. So it's actually going to be a fraction, so it's really the square root of 1. You say, well, what am I going to get up here? How do I square something and get 1? It's just 1. And the square root of 9 is 3. So 1/3 times 1/3 will be 1/9. So what's this going to be? Well, you think, hey, let's just do the square root of 49 and the square root of 16. So that'll be 7/4. The square root of 1.69. 1/6. I've seen that number before. Oh, here it is here. It's 13 squared. 169. But this is 1.69. So it's like, make that bigger. It's like 169, which I do know the square root of, over 100, right, to kick that decimal back and make this. So this is 1.69. The square root of 169 is 13, so it's like 13/10. Well, it's not like 13/10. It is 13/10, or 1.3. Okay, will that work here? Because we know the square root of 9, and that's 9/100, right? Because just think, how are we going to get back to 9? We go 1, 2, multiply by 100. The square root of 9 is, that's 3/10, or 0.3. Okay? And you can verify all of these, of course, with your calculator if you so desire. Every number can be expressed as a square root. So 6 is the square root of some number. Well, that number is, I got to square the 6, right? So 36. 6 squared is 36. 15 is the square root of, and we can just look in our chart there, right? 225. 1.2. Okay, wait, we know 12 squared is 144, so 1.2 squared must be 1.44. And I'm going to extend this, right? Because I'm writing this, I'm just going to extend that a little bit too. So always make sure when you're writing a radical that it extends over the radicand. 2 squared is 4, 5 squared is 25. So that we get the, whoops, I left the pen hovering there. We get the square root of, whoops, and I'm actually just getting out my eraser as I just found a mistake on my key, and that's fixed. And now let's move on to cube roots. Cube roots. If x is the cube of r, then r is the cube root of x. If x is the cube of r, then to uncube things, right, we have to undo the cubing. We do that by taking the cube root of both sides. So we say the cube root of r cubed is, well, you're basically just undoing what's there is r. So when we take the cube root of this side, we get r, and the cube root of x is the cube root of x. So what number when cubed gives us 27? That number is 3, right? 3 times 3 is 9, times 3 is 27. Now here, oh, this is interesting. This is a negative number, and it's actually negative 4. And so what you have to think is I'm taking negative 4 times negative 4 times negative 4, which is, okay, negative 4 times negative 4 is 16 times negative 4. This was the first two. And 16 times negative 4 is negative 64. So the cube root of a negative number is negative. Why? Well, we've got 3 of them. And any pair of negatives together will make a positive. So if we had 5 of these, we'd be able to pair up and then pair up and be left with a negative at the end. Whereas with a square, we're only pairing. So 2 positives or 2 negatives. So kind of interesting, right? The cube root of a positive number is positive, and the cube root of a negative number is negative. List the first 10 perfect cubes. So I'm going to pause, I'm going to write them in, you're going to pause, you're going to write them in, and we'll meet back here and compare. On your mark, get set, go. And we're back, right? Now let's just show you one of these. So Claire, let's do 7 cubes. So 7, how do we cube? We use the caret. This here is a caret, because this here is a wabbit. And we go to the power of 3, hit enter, right? Just same, you can do, if you're doing a 5th power, you'll go 7 to the 5th, right? And I think later on we actually do 5th powers and we do 4th powers. And that's how you're going to do all of those, so I'm not going to show you that again. Not every number is a perfect cube. Their values can be estimated by comparing them to perfect cubes, right? So again, you may not know all these numbers, but you should be familiar. You should be able to say, hey, 343 has a cube root, right? The 216 is a cube. I don't know what they're the cube of necessarily, but I know they have a cube root, so I can go to my calculator, punch it in, and find out they are a perfect cube, right? Or they have, by being a perfect cube, it means you have a cube root. But not every number does, like 58. But 58 is pretty close to 64. So let's come up with a guess. I mean, 58 is a lot closer to 64 than to 27. So our answer is going to be a lot closer to 4 than it is to 3. So I'm going to guess. I'm going to say, okay, how about 3.7? Negative 100. Okay, it's negative, so I know its cube root is negative. 100, well, between 4 and 5, 36 numbers away from there, 25 numbers away from there. So I'm going to guess 4.7. And the cube root of 450, between 343 and 512. It's like 100, so it's closer to 8 than it is to 7. So I'm going to guess, let's say 7.7. Okay, now those are estimates. Let's get the for real. So how do we do a cube root on our calculator? Here's how. There actually is a cube root button. It's in the math menu, and it's number 4, and the fastest way to 4 is this. You don't want to arrow down. You put in the number 58, and you hit enter. And we see that it's really 3.9. So it was a lot closer to 4. Now I want to do another cube root. Well, here's how I can do it. Let's go second function, enter, which says copy that. And I'm going to arrow back and enter negative 100. And you'll notice how it extends. If I go to the right, it's extending the radical sign out. And we'll hit enter, negative 4.6. And the cube root of 450. So again, so I got 2 choices, right? I can go math 4, cube root, and then 450. And hit enter, and we get 7.7. Nice, good guess. Off by a couple of tenths here, right? You're not going to be perfect. And again, we're just guessing, so for estimation purposes. Some perfect cubes have fractions or decimals, right? We got like 1/8, and so we say, what cubed gives me 1? And what cubed gives me 8? So the cube root of 1/8 is 1 over 2. What cubed gives me 27? 3 cubed, right? Or what's the cube root of 27? What cubed, which is the same way of saying what's the cube root? This is 5. 0.512. Okay, let's do that. It's like this, right? But it's, so it's the cube root of 512. This has a cube root, right? Now to get 512, we got to go 1, 2, 3. So divided by 1,000. And the cube root of 512 is 8, and the cube root of 1,000 is 10. So it's 8 over, it's nice, like you do a triangle in there. It's 8 over 10 reduces to 4 over 5. Okay, so the cube root of 512, or 0.512, let's give that a try. So second enter, 0.512, you don't really need the leading 0, is 0.8, math, enter, change it into a fraction, and 4/5. Yay. Every number can be expressed as a cube root. So 5 is the cube root of what? It's the cube root of 5 cubed, which is 125. -6 cubed, -6 times -6 is positive 36, times a negative gives you negative 216. Since I made such a long negative sign, then I need to extend this out. 2.3, okay, I'm actually just going to cube that on my calculator, right? So 2.3 cubed, I could cube 23 and do so. 12.167. 12.167. Exact value, no rounding, because if I were to go like the cube root of 12.7, whoops, I can't do a cube root that way, math, 4, and I said, oh, we'll just round it to the nearest, oh, you know what, let's actually round it to the nearest 10th. That is not 2.3. It rounds to 2.3, but it's not 2.3, so use exact values. Okay, I want the cube root of something to be 4. The cube root of 64 is 4, and the cube root of 27 is 3, and so there we go. What's next? Higher roots. Go higher. Similarly, 4th roots of 16 are 2 and -2. Okay, so when we have an even power, 2, 4, then, you know, because if we take -2 to the 4th, right, -2 times -2 times -2 times -2, 4 times, right, these two negatives pair up, right? So, I mean, if I multiply this, I'm going to get 4 times -2 times -2. And if I multiply here, I'm going to get -8 times -2, and that's going to give me 16, right? I just think of it this way. These guys make a positive, these guys make a positive, and we've got two positives multiplied together, right? We can pair up negative signs. When we use the radical sign, then we are only talking about the positive or principal 4th root, right, or square root, or etc. List the first 10 perfect 4th powers. Okay, you're not going to sit and watch me do that, so let's both go away. We'll figure them out. Okay, you know how to do a 4th power. One more time, right? We're going to do 7 to the 4th, clear. 7, use the upside down V, that's to the power of. It'll kick it up here, depending on your calculator firmware. And that's 2401. 2401. So 1 is done, go do the rest, then come back. And we're back. And here they are. So, you know, just check them over. If you find any differences, then try it again. And if you're still finding differences, then let me know, and I'll put up the infamous little text box to say, whoops, that should have been something else. Okay, without using a calculator, estimate. So 3,600, right? Well, it's not between 6 and 7. It's between 7 and 8. 3,600. I'd have to add like 1,200 to this, and about 400 to that. So it's, you know, it's more than 7.5. I'm going to go with 7.7. 6. And I'm going to use my calculator to verify that, and I'll show you now how to do a fourth root, right, which will come in handy when we also do the fifth root. But let's do fourth root of 650. Pretty close to 5. You know, like closer to 5 than to 6, because 650 is only 25 away from that, and it's like, whoa, pretty far away from that. Okay, how do we do a fourth root? Fourth or higher root. So here's what we do. I want to do a fourth root. So I'm just going to clear this. So I have to put in what root I want. I want the fourth root. Go to the math menu, and we want number 5, right? It says the xth root. And as soon as you do that, you see how you get the radical, and you've got the index there, kind of. And then you type in the number, 3600. Okay, and if we kick to the right, there, it looks very nice. And we hit enter, and we get 7.7 rounded to the nearest tenth. Actually, 7.75. So 7.7 is the for real value. 650. All right, this time it's probably easier to go second function enter. Right, and we can move over and type in 650. Now I got an extra 0 there. We'll just hit delete to get rid of it. And again, we can arrow out of it if we want. And we get 5.0. Wow. So 5.05 rounded to the nearest hundredth, and 5.0. You know, and don't cascade your rounding, right? So if I'm rounding to the nearest hundredth, it's 5.05. If I'm rounding to the nearest tenth, then it's 5.0. Hundredth, tenth, and estimation off by a fair bit. It's like really close to 5. The fifth root of negative 32 is negative. So odd roots, again, right? So negative 2 to the fifth. What does that mean? It means I need 5 of them. 3, 4, 5. These guys will pair up. They'll make a positive. These guys will pair up. They'll make a positive. A positive times a positive is positive, and then we still have one negative left over, and so that's where we get odd roots, right? You'll always be able to collect even together and be left with 1. So the fifth root of negative 32 is negative 2, since negative 2 to the fifth is negative 32. And remember, odd roots, you know, the odd root of a negative is negative, the odd root of a positive is positive, right? Whereas with even roots, we are only doing principal roots, right? So we know that there's a positive value and a negative value. This symbol, the radical symbol, means you're only using the positive value. List the first 10 perfect fifth powers. Okay, so pause, I'm going to fill it in, you pause, you fill it in, come. And we're back. So hopefully we all agree on this. And let's do the fifth root of 50. Okay, pretty close to 2. Pretty close to 2. How about 2.3? Right, and then we'll do the actual value. And the fifth root, the root of a negative, remember, the odd root, if that's a square root of negative 600, it's like, yeah, you can't do it. Okay, you cannot do an even root of a negative number, but you can do an odd root, which makes this negative. 600 between 3 and 4, really pretty close to about halfway, so let's go negative 3.5. Okay, now let's practice fifth roots. So this time, here, let's clear that. So I want a fifth root, so you put in a 5, you go math, number 5, or you can arrow down. I don't because it takes forever. And then hit enter. So the fifth root of, and we want 50, just hit enter. 2.2, right, rounded to the nearest tenth, 2.2. And we want the fifth root of negative 600. I'm just going to go second function enter, arrow in, go negative. That's your key for making numbers negative. This is the minus sign, 600. You want it to look pretty. There it is, very nicely underneath the radical sign. Hit enter, negative 3.6. And I guess that's equal. Okay, long lesson on roots. we're done. Oh, and then there's the summary, of course, right? So let's drag this out over half an hour. A radical is an expression of the form the nth root, where n is a natural number. Natural numbers are the counting numbers, right? 1, 2, 3, 4. Only we don't do first roots, right? We do square roots and cube roots and fourth roots. The symbol, this symbol is called the radical sign. N is the index, and x is the radicand. If the index is odd, the radicand exists for all values, right? We can take the odd root of a positive or a negative. If the index is even, then the radicand must be greater than or equal to 0. If n is even, the expression this represents only the positive square root. Okay, so this says we cannot take an even root of a negative, and this says that if it's even, we know that then there are two roots, positive and a negative, and this symbol represents only the positive root. So for example, the root of 4 is 2, and if I say that x squared equals 4, then x is plus or minus 2, right? There are two solutions to this, and if we just want to take the square root, then there is one. If you write it this way, x equals, then you have to go plus or minus the square root of 4. So in solving something like this, when you take the root of both sides, right, so if you were to write the root of x squared, you would actually do a plus or minus there as well, but that comes down to this. You don't need them on both sides because they'll just pair up as positives, negatives, and so on. Okay, not to worry about. There we go. That is radicals, and I'm sure you have some work to do now.